Hello students, welcome to the new episode of Conceptual Physics. I am Lalit Midha and today we will start first chapter of very interesting unit known as heat, and the chapter name is Thermal Properties of Matter. All the properties of material or matter related with heat and temperature we will discuss in this chapter, right? First topic is temperature, physical quantity which is measure of hotness or coldness of the body. It tells us how hot or cold the body is. When you touch a piece of ice cube, then you will feel cold. Why? Because the temperature of ice cube is much less than your body temperature. If you touch hot cup of tea, then you will feel hot. Why? Because the temperature of hot cup of tea is much higher than your body temperature. So this quantity tells us about the hotness or coldness of the body. Physical quantity means the quantity which we can measure. We can measure temperature of the body, right? So temperature is physical quantity. Next, heat. Heat is a form of energy transferred between the two bodies due to difference in temperature, and this energy is due to motion of atoms or molecules present inside the material. Inside the material at normal temperature, atoms or molecules vibrate about their mean position, and heat always flows from higher temperature body to lower temperature body. When you touch ice, then your body temperature is more than ice. So this energy will move from your body to the ice and ice will melt, right? Next, temperature and heat both are scalar quantities. Scalar quantities are the quantities having only magnitude, right? No direction. So both heat and temperature both are scalar quantities. Now let us discuss about the units. First is temperature, and the SI unit of temperature is Kelvin, represented by capital K. Other units are degree Celsius, degree Fahrenheit, etc. Second is heat. Joule is the SI unit of heat, and there is one more unit, that is calories, and 1 calorie is equal to 4.2 joule, right? Now the next point is thermometry. What is the meaning of thermometry? Thermometry is the branch of heat which deals with measurement of the temperature. So in this specific branch of heat, we will measure the temperature of different bodies. Instrument used to measure temperature is called thermometers. So thermometers are the instruments used to measure temperature. Normally to measure body temperature we use thermometers. Construction of thermometers depends on some physical properties that changes with the temperature. Because we have to measure the temperature, so we need this type of material that will change with the increase in temperature. That is why we are saying physical properties. For any thermometer, we need two reference points. Right, we have to fix two reference points for measurement of temperature by using any scale. First is lower fixed point, that is also represented by LFP, lower fixed point. And what is this? This is the ice point. Ice point means melting of ice. Melting of ice is known as lower fixed point, and for degree Celsius, everybody know that at 0 degrees Celsius ice will start melting. So 0 degrees Celsius is the ice point for degree Celsius scale. But for Fahrenheit scale, it is different. It is 32 degree Fahrenheit. So for Fahrenheit scale, the melting of ice is at 32 degree Fahrenheit, right? The value is different in different scale, but the temperature is same. The temperature is when ice will melt, that temperature is known as ice point. Second is upper fixed point, that is represented by UFP, upper fixed point, and it is also known as steam point, boiling point of water at normal atmospheric pressure. So boiling point of water at normal atmospheric pressure is known as steam point, and it is the upper fixed point for any journals or standard scale, right? For degree Celsius, we know at 100 degrees Celsius water will start boiling. So for degree Celsius scale, 100 degree Celsius is steam point, but for degree Fahrenheit it is different. It is 212 degree Fahrenheit. Value is different, but temperature is same. Temperature is steam point, that is equal to 100 degrees Celsius, or in some other unit degree Fahrenheit it is 212 degree Fahrenheit, right? Next point is different scales of thermometer. Before starting this topic, let us see a simple thermometer used to measure body temperature. So see this thermometer. Here we have two different scales. Upper scale is degree Celsius scale and lower scale is degree Fahrenheit scale. Upper scale starts from 37 degrees Celsius to 42 degrees Celsius, and lower scale starts from 94 degree Fahrenheit to 108 degree Fahrenheit. You can see in the diagram, normal body temperature is 37 degrees Celsius, and in Fahrenheit it is 98.7 degree Fahrenheit. So temperature of the body is same, but if you want to represent this temperature in degree Celsius, then it is 37 degrees Celsius. If you want to represent this temperature in degree Fahrenheit, then it is 98.7 degrees Celsius. Means temperature of the body is same, but the value in different scale is different, right? Different scales of temperature. First, let us understand the concept behind mercury thermometer. Rise in mercury level is directly proportional to the increase in temperature. If we increase the temperature of the mercury, the level of the mercury will also increase, right? It is based on expansion of liquids. We will see this point in detail in topic thermal expansion. So here we have different scales of temperature. First one is Celsius scale, and the lower fixed point, that is ice point, is 0 degrees Celsius. Second is Fahrenheit scale, and the lower fixed point, that means ice point, is 32 degrees Celsius. Similarly, we have Reaumur scale, lower fixed point 0 Reaumur. Next, Rankine, lower fixed point 492 Rankine. Next is Kelvin scale, that is 273.15 Kelvin is lower fixed point. Lower fixed point means ice point when ice will start melting. Last is the new or some faulty scale. Faulty scale means scale having some error, and the lower fixed point is X. So here the lower fixed point is having different value for different scale. For ice it is 0 degrees Celsius, for Fahrenheit it is 32. Means the temperature is same, but the value in different scale or different unit is different, right? Like God is same, but you can give any name to the God. You can say it's Lord Krishna, you can say it's Jesus Christ, you can say Allah, or you can say Guru Nanak, but ultimately it is same. So temperature is same when ice will melt, but the value of this temperature in different units is different. Similarly, upper fixed point, that is steam point, where water will boil. So steam point is, for Celsius scale it is 100 degrees Celsius, for Fahrenheit it is 212 degree Fahrenheit, for Reaumur it is 80 Reaumur, for Rankine it is 672 Rankine, and for Kelvin it is 373.15. Similarly, for a new scale, let us suppose it is Y, right? So upper fixed point, that is the steam point where water will boil, is same, temperature is same, but the value of temperature is different in different units. For degrees Celsius, lower fixed point is 0 degrees Celsius, upper fixed point is 100 degrees Celsius. So there are 100 slots, gap is 100. So there are 100 slots in this Celsius scale. Second is Fahrenheit scale, starting from 32, lower fixed point, and upper fixed point is 212 degree Fahrenheit. That means there are 180 divisions or 180 slots in this Fahrenheit scale. Next is Reaumur scale. Slots are 80 because lower fixed point is 0, upper fixed point is 80. So there are 80 divisions or 80 slots in this scale. Next, Rankine, starting from 492 to upper fixed point 672. So there are 180 divisions in this scale, or you can say there are 180 markings on this scale. Next is Kelvin scale, starting is 273.15, that is lower fixed point, and upper fixed point is 373.15. So the gap is 100. That means there are 100 divisions or 100 slots in this scale. Similarly, last, new or faulty scale, starting from X and upper fixed point is Y. So there are how many divisions? Y minus X divisions. That means there are Y minus X slots in this scale. Let us suppose this gap from lower fixed point temperature to upper fixed point temperature, this gap, this length is L, right? This length is L, and this length is same for all the scales, because ultimately the lower fixed temperature and upper fixed temperature is same, but the values in different scales is different. So according to this condition, increase in temperature is proportional to the rise in mercury. That means this L is proportional to difference in temperature, increase in temperature. So for first scale, Celsius scale, we can say 100 minus 0, increase in temperature, is proportional to the height of mercury, that is L. So 100 minus 0 is proportional to L, this height gap. For Fahrenheit scale, it is 212 minus 32 is proportional to L, because the gap in temperature or rise in temperature is 212 minus 32, and that is proportional to the length or height. Next, for Reaumur scale, 80 minus 0 is directly proportional to L, rise in temperature is 80. For Rankine, it is 672 minus 492 is proportional to L, means rise in temperature is this, and that is proportional to the height of mercury. In Kelvin scale, 373.15 minus 273.15 is proportional to this length L. For a new scale, it is Y minus X proportional to L. Y and X, this is the rise in temperature, that is proportional to L. So here L is proportional to the rise in temperature from lower fixed point to upper fixed point, right? Now let us suppose we have T temperature. Now all the scales will measure same temperature T, right? Suppose degree Celsius scale is showing C reading for temperature T. Fahrenheit scale is showing F reading for temperature T. Reaumur scale R reading, Rankine scale RA reading, and Kelvin scale is showing K reading for temperature T, and new or faulty scale is showing Z reading for temperature T. Temperature is same, but the readings at different scale will be different. Why? Because their units are different. Their lower fixed point and upper fixed points are different, but the height of mercury will be same for all the different scales at T temperature. Suppose the height of the mercury is x with respect to lower fixed point. So height is x. So this height is proportional to increase in temperature. So what is the increase in temperature here? From 0 to C. So increase in temperature is proportional to height of mercury. So C minus 0 is proportional to x. Here for Fahrenheit scale, it is from 32 degree Fahrenheit to F reading. So increase in temperature is F minus 32 and it is proportional to height of mercury. For Reaumur scale, it is from 0 to R. So R minus 0 is proportional to height of mercury. For Rankine, it is 492 to RA. So it is RA minus 492 proportional to X, height of mercury. For Kelvin scale, it is from 273.15 to K Kelvin. So K minus 273.15 is proportional to X, height of mercury. Similarly, for the new or faulty scale, it is from X to Z. So Z minus X temperature increase is proportional to height of the mercury X. Now all the scales are having same value of X and same value of L height, right? So X by L ratio is same for all the different scales. So let us calculate X by L ratio. First, for degree Celsius, it is C minus 0 divided by 100 minus 0. And for Fahrenheit, it is F minus 32 divided by 212 minus 32. And it is equal to R minus 0 divided by 80 minus 0. For Rankine, it is RA minus 492 divided by 672 minus 492. Equal to, for Kelvin scale, it is K minus 273.15 divided by 373.15 minus 273.15. And for the new or faulty scale, it is Z minus X divided by Y minus X. All these ratios are equal to X by L. X and L is same for all the scales. So all the ratios are equal and this formula is very, very important. And we use this formula to convert one scale reading into another scale. If you want to convert degree Celsius scale reading to Fahrenheit scale, then you can use these two formulas. If you want to convert Fahrenheit into Kelvin, then you can use these two formulas. If you want to convert Kelvin into new scale, some faulty scale, then you can use these two formula, right? So this formula is very, very important and you have to remember it. Got my point? Now the general condition for all the scales. If Z is the reading of the scale, then Z minus lower fixed point of that scale divided by upper fixed point minus lower fixed point. For Celsius scale, C is the reading. So C minus 0 divided by 100 minus 0. 0 is lower fixed point and 100 is upper fixed point. Same thing is for Fahrenheit scale and all the remaining scales. Now this is 100, this is 180, this is 80, this is 180, this is again 100. If you cancel out with 20, then you will get C by 5, F minus 32 by 9, R by 4, RA minus 492 divided by 9, K minus 273.15 divided by 5. You have to remember this condition. We will use this condition whenever we have to convert one scale reading to another scale reading. And these are the different readings of the scales. Now we know that lower fixed point for Celsius scale is 0 and upper fixed point is 100. So 100 degrees Celsius change is equal to 180 degree Fahrenheit change. So this change is equal to this change. So 1 degree Celsius change will be equal to 1.8 degree Fahrenheit change, or you can say 9 by 5 degree Fahrenheit change. right? Similarly, 100 degrees Celsius change is equal to 100 Kelvin change in temperature. So 100 degree Celsius is 100 Kelvin change in temperature. So 1 degree Celsius change in temperature is equal to 1 Kelvin change in temperature. Here we have change relation. 1 degree Celsius change is 9 by 5, that is 1.8 degree Fahrenheit, and 1 degree Celsius change is equal to 1 Kelvin change in temperature. Now let us see some important graphs. Graph between degree Fahrenheit and degree Celsius. We know some basic conditions that at 0 degree Celsius, that is the lower fixed point, Fahrenheit reading is 32 degree Fahrenheit. So 0 degree Celsius is equal to 32 degree Fahrenheit. So this is the common point. 0 degree Celsius and this is 32. So this is the point for this condition. 100 degree Celsius temperature is equivalent to 212 degree Fahrenheit. 212 degree Fahrenheit. So the common point for 100 and 212 is this point. If you connect these 2 points, you will get graph between degree Fahrenheit and degree Celsius. You can calculate the slope also. What is slope? Slope is tan theta. Tan theta is perpendicular upon base. This gap is 180 and this gap is 100. So tan theta is 1.8, or you can say 180 divided by 100, right? So slope is 1.8. Second graph is graph between Kelvin scale and degree Celsius scale. We know some basic condition. Lower fixed point is 0 degree Celsius, but for Kelvin it is 273.15. So 0 degree Celsius is equivalent to 273.15 Kelvin. So this is the point. 100 degree Celsius is equal to 373.15 Kelvin. So 100 is equivalent to 373.15, and this is the common point. Again, join these 2 points, you will get the graph between Kelvin scale and degree Celsius scale. You can calculate the angle also. This gap is 100 and this gap is also 100. So tan theta is perpendicular upon base, that is equal to 1. So theta is 45 degree, right? Next point is numerical based on different scales. First, convert minus 10 degrees Celsius into Fahrenheit scale. So reading of Celsius scale is given to us, minus 10 degrees Celsius, right? C is given to us. They are asking what is the value of F, means Fahrenheit scale reading. So put the value C equal to minus 10 in this relation and calculate the value of F, that is Fahrenheit scale reading, and you will get 14, means minus 10 degrees Celsius is equivalent to 14 degree Fahrenheit in Fahrenheit scale, right? Second question. At what temperature degree Celsius thermometer reads the same value as Fahrenheit thermometer? Means reading of degree Celsius should be equal to reading of Fahrenheit scale. So both the readings are equal, that means C and F both are equal. So put C equal to F in the formula. F is equal to C and find out the value of C, that is minus 40. Means minus 40 degrees Celsius is equivalent to minus 40 degree Fahrenheit. That means at this temperature both the scales will give us same value, minus 40. Third problem. Find temperature at which reading of degree Fahrenheit thermometer is 5 times that of degree Celsius thermometer. So here condition is reading of Fahrenheit scale should be 5 times of degree Celsius scale. Again put the value F equal to 5C according to the question in the formula. So replace F with 5C and solve it. You will get 10 degrees Celsius. So at 10 degrees Celsius, reading of Fahrenheit scale will be 5 times. That means 50 degree Fahrenheit. Right? Fourth problem. A faulty thermometer has its fixed points marked as 5 degree and 95 degree. So this is lower fixed point, this is upper fixed point. The temperature of the body as measured by faulty thermometer is 59. So this is not correct temperature of the body, but the reading of faulty thermometer is 59 degree. Find the correct temperature of the body in degree Celsius and find out the correction applied to the scale. We have to find out the correction also, and we have to find out the correct temperature of the body also. So we know lower fixed point is 0 degree Celsius for Celsius scale, and for this faulty scale it is 5 degree. Upper fixed point is 100 for Celsius scale, but for faulty scale it is 95. And the reading of faulty thermometer is 59. We have to find out the reading of degree Celsius scale, right? So use the formula of new or faulty thermometer relation and degree Celsius relation. Compare it. Z is given to you 59. Lower fixed point and upper fixed point both are given to you. And here it is 0 and 100. Solve it. You will get C equal to 60. That means the correct body temperature is 60 degrees Celsius, but this scale is measuring 59. So what is the error? Error is 1 degree. So what is the correction? Correction needed is plus 1 degree Celsius. Right? Fifth problem. A body is at 122 degree Fahrenheit, but its temperature is recorded as 52 degrees Celsius on a 40 Celsius thermometer, for which melting point is given to you. That means lower fixed point is given to you 5 degrees Celsius, but originally degree Celsius scale is having 0 degrees Celsius as lower fixed point, but here it is 5 degrees Celsius. Find the upper fixed point. So we have to find out the upper fixed point for this faulty thermometer. Reading of degree Fahrenheit scale is given to you 122. This is correct value, that is F. Faulty thermometer reading is also given to you 52 degrees Celsius, that is degree Celsius. Now this is new or faulty thermometer, and this is for Fahrenheit thermometer. So F minus 32 divided by 180 is Z minus X divided by Y minus X. Lower fixed point and the reading both are given to you. Upper fixed point is not given to you, and they are asking find out the value. So put the value of F 122. Z reading of faulty thermometer is 52, and solve it and find out the value of Y. You will get Y as 99 degrees Celsius. So the upper fixed point of this faulty thermometer is 99 degrees Celsius. Got this? Next point is different types of thermometers. We have variety of thermometers for different purpose. To measure human body temperature, normally we use mercury thermometer, that is liquid thermometer. We have gas thermometers also to measure very high range of temperature. We have resistance thermometer also to measure up to 1200 degrees Celsius temperature. There are some thermometers based on triple point of water also. All we have to discuss in this point, right? So first let us start with liquid thermometer. Liquid thermometers are based on thermal expansion of liquid. Means as we increase the temperature of the liquid will expand, right? So what is the principle? Increase in volume of mercury is directly proportional to increase in temperature. That means as we increase the temperature of the mercury, the volume of the mercury will also increase. Here we are taking a pipe, that is also known as capillary tube, and this is mercury bulb. Here we have mercury. If we increase the temperature of this mercury, then mercury will expand. There is no space here, so mercury will move in upward direction. So level of the mercury will increase. So here area of this tube is fixed. We are neglecting any expansion in area of this tube. This tube is also known as capillary tube, right? So there is no change in area. So how volume of the mercury will increase? Area is fixed, so length will increase or height will increase, then we can say volume of the mercury is increasing, right? So ultimately volume is proportional to length, and increase in volume is also proportional to increase in temperature. So as we increase the temperature of the mercury, height of mercury level will also increase, right? So let us take a simple example. This is, let us suppose, the height of 0 degree temperature. So height of 0 degree temperature is L0. Height of 100 degree Celsius temperature, mercury height, is L100. So at 100 degree Celsius, height of the mercury or level of the mercury is L100. So according to this relation, increase in temperature from 0 to 100. 0 to 100 is proportional to increase in length. Length increment is from L0 to L100. So 100 minus 0 is proportional to L100 minus L0. This is our first equation. Now for some temperature T, let us suppose the height of the mercury is LT. So length of the mercury column is LT. So at 0 degree Celsius, we know height is L0. At T degree Celsius, height is LT. So increase in temperature is directly proportional to increase in length. So T minus 0 is proportional to LT minus L0. This is our second equation. Let us divide these two equations. So second divided by first is T divided by 100 is equal to LT minus L0 divided by L100 minus L0. Right? From this equation you can calculate the value of T, that is the temperature where height of the mercury is LT. So if you know the height of mercury LT, then you can calculate the temperature of that body also, right? And we have to remember this formula. Now some points related with mercury. Mercury freezes at minus 38.8 degrees Celsius, and the boiling point of mercury is 356 degrees Celsius. So we cannot measure very low or very high temperature by using mercury thermometer, right? So the range of the mercury thermometer is only up to 300 degrees Celsius. But if we replace the air with N2 gas, if we fill N2 gas, then we can increase the range of the mercury thermometer to 500 degrees Celsius, because as we change the gas, the boiling point of the mercury will change, right? It will increase. So when we fill N2 gas, we can increase the range of the mercury thermometer up to 500 degrees Celsius, right? Second type of thermometer, that is gas thermometers, and these are based on thermal expansion of gases. As we increase the temperature of the gases, the gas will expand, right? And we have an ideal gas equation for gases, that is PV equal to nRT. Standard equation: P is the pressure of the gas, V is volume of the gas, T is temperature of the gas in Kelvin, where N is number of moles. The value of N is mass of the gas divided by molecular mass, right? R is gas constant. So for the given gas, these two values are constant. N and R are constant. So PV equal to nRT is the basic equation for these type of gas thermometers. First type is constant volume gas thermometers. Constant volume means we will maintain volume of the gas constant. So volume of the gas is constant. So if volume is constant, for the given gas N and R both are constant, so pressure is directly proportional to temperature. So as we increase the temperature, pressure of the gas will also increase. So let us suppose at 0 degrees Celsius, pressure of the gas is P0. At 100 degrees Celsius, pressure is P100. Right? Two reference point. 0 degrees Celsius, we know it's P0. At some temperature T degrees Celsius, the pressure in the gas is PT. Right? So now, what is the increase in temperature here? It is 100 minus 0. What is increase in pressure? P100 minus P0. And increase in temperature is proportional to increase in pressure. So 100 minus 0 is proportional to P100 minus P0. Similarly, increase in temperature is T minus 0 is proportional to PT minus P0. This is our second equation. Divide these two equations. Second divide by first. Then T divided by 100 is equal to PT minus P0 divided by P100 minus P0. If you find out the value of T is PT minus P0 divided by P100 minus P0 into 100 degrees Celsius. So this is the value of temperature when pressure of the gas is known at this temperature. Right? We have to remember this formula. Second type is constant pressure gas thermometers. Means here pressure is constant. If pressure is constant for the given gas, volume of the gas is proportional to temperature. Right? So increase in temperature will be proportional to increase in volume. Same concept. 0 degrees Celsius, volume is V0. 100 degrees Celsius, volume is V100. Two reference point. So increase in temperature is 100 minus 0 is proportional to increase in volume. V100 minus V0. Right? This is our first equation. Now let us suppose T is the temperature of the gas where volume of the gas is Vt and at 0 degree it is V0. So what is the increase in temperature? It's 100 minus 0 is proportional to Vt minus V0. Right? This is our second equation. Divide these two equations. T divided by 100 is Vt minus V0 divided by V100 minus V0. Find out the value of T. So T is Vt minus V0 divided by V100 minus V0 into 100 degrees Celsius. This is the value of temperature when volume of the gas is Vt. Got my point? Third type of thermometer is resistance thermometer. This is based on the concept that as we increase the temperature of metal, its resistance increases. So in this type of thermometer, we need some material whose resistance will change with temperature. And here we employ platinum as thermometric substance. That means here if we increase the temperature of platinum, then its resistance will change. Now what is the principle? Principle is the increase in resistance of platinum wire is directly proportional to increase in temperature. That means the increase in temperature is directly proportional to the resistance of platinum wire. Suppose at 0 degrees Celsius, resistance of platinum wire is R0. 100 degrees Celsius, resistance is R100. Again, we are using two reference point, lower and higher. Right? So, what is the increase in temperature? Increase in temperature is from 0 to 100. So, 100 minus 0 is proportional to increase in resistance. R100 minus R0. This is our first equation. At 0 degrees Celsius, resistance is R0. Let us suppose at temperature T degrees Celsius, resistance is RT. Then increase in temperature is T minus 0 is proportional to increase in resistance RT minus R0, and this is our second equation. Divide these two equations. Second divide by first. So T divided by 100 is equal to RT minus R naught divided by R100 minus R naught. So from this we can calculate the value of T. T is RT minus R naught divided by R100 minus R naught into 100 degrees Celsius. So if we know the resistance of platinum wire at some temperature, then you can calculate the temperature by using this formula, right? Range of resistance thermometer is from minus 272 degrees Celsius to 1200 degrees Celsius. We can measure up to 1200 degrees Celsius by using a resistance thermometer, right? Next point, measurement of temperature based on triple point. In the previous cases, we took two reference points, lower melting point of ice, higher boiling point of water, right? But in modern thermometry means measurement of temperature. Instead of taking two reference point, here we will take only one reference point, that is triple point of water. What is the meaning of triple point of water? It is the temperature at which all the three states of water, ice, water and water vapor, coexist. So when all the three states are available at the same time, this temperature is our reference point, and this is known as triple point temperature, and its value is 273.16 Kelvin, right? So instead of taking two reference points 0 and 100, here we will take only one reference point. That temperature is 273.16 Kelvin. The previous was in degrees Celsius, but here it is in Kelvin. So at this triple point temperature, pressure is, let us suppose, PTR, and resistance of platinum wire is RTR. And at T Kelvin temperature, pressure is PT and resistance is RT. So 273.16 temperature, triple point temperature, is proportional to triple point pressure, right? And T Kelvin temperature is proportional to T Kelvin pressure. So divide these two. We will get T divided by 273.16 is equal to PT divided by PTR. So from this you can calculate the value of temperature in Kelvin, that is PT divided by PTR into 273.16. You can see we are taking triple point pressure as reference point. It is coming in denominator. With respect to triple point temperature, pressure is coming in denominator, right? Similarly, resistance at triple point temperature is RTR, so it is proportional to RTR, resistance at triple point. T Kelvin temperature resistance is RT, so T Kelvin is proportional to RT. Again divide it in the same manner. Again you will get similar type of result. T Kelvin temperature is RT divided by RTR into 273.16 Kelvin temperature. Here T is in Kelvin. Right? These two are the formulas for triple point. Similar to these two, we can form volume formulas also for triple point. Right? Let us see some numericals based on thermometers. The reading of corresponding to ice point and steam point for a constant pressure gas thermometer. This is gas thermometer. And the reading is given to you 500 cc, that means centimeter cube, and this is volume because pressure is constant. And for steam point, the reading is 545 cc centimeter cube. The reading corresponding to the room temperature is 510 centimeter cube. Find the room temperature. This is the problem. We have a formula for this. 0 degrees Celsius, volume is given to you 500. Steam point means 100 degrees Celsius, volume is given to you 545 cc. And room temperature we have to find out. So at T degrees Celsius, volume is 510 cc. Put in this formula, This is 510, V0 is 500, V100 is 545. Again 500, solve it, you will get 22.22 degrees Celsius. So room temperature is 22.22 degrees Celsius. Second problem, the resistance of platinum resistance thermometer is found to be 11 ohm. When dipped in triple point, so this problem is related with the triple point or modern thermometry. Find temperature when resistance is 28.887 ohm in degrees Celsius, right? We have to find out answer in degrees Celsius. So triple point formula is T Kelvin. It is in Kelvin. RT divided by RTR into 273.16. Reading is given to you RT 28.887. At triple point it is given to you 11 because here we have only one reference point. In the previous case we were having two reference point. Here only one. So RTR. So 11 28.887, solve it, you will get 717.32 Kelvin, but they are asking find out answer in degrees Celsius. So we have to use the relation for degrees Celsius and Kelvin. Put the value of Kelvin. Kelvin is 717.32. 55 will cancel out. 273.15. When you subtract it, you will get 444.17 degrees Celsius as answer. Right? Now let us see one more example. Two absolute scales A and B have triple points of water defined to be 200A and 300B. That means instead of 273.16, scale A and scale B are showing 200A and 300B. A temperature is measured on these scales as TA and TB. That means some temperature T is measured by these two scales as TA and TB. The problem is what is the relation between TA and TB? So we have to find out the relation between TA and TB. Triple point temperature is given in the question, 273.16 Kelvin. So for scale A, this temperature is shown by scale A as 200 and scale B as 300. So 273.16 is proportional to 200A, 273.16 as 300B. Now some temperature is measured as TA and TB. So let us suppose that temperature is T Kelvin. So T Kelvin is measured as TA by scale A and T Kelvin temperature is measured as TB by scale B. Now divide these two equations, 273.16 divided by T, 200 divided by TA. Here 273.16 divided by T is equal to 300B divided by TB. Now because these two data are exactly equal, right? If these two are exactly equal, that means the remaining two are also equal. So compare it. 200 divided by TA is equal to 300 divided by TB. Solve it. You will get TA is equal to 2 by 3 TB. Right? I hope you understood this.